Right. So in this experiment, we are discussing about the Zener diode VI characteristics. Zener diode is a heavily doped diode. Previous video we are discussing about the PN junction diode VI characteristics. What is the aim of this Zener diode VI characteristics? Means V means voltage, I means current characteristics of a Zener diode. From this characteristic curve, we can find the Zener breakdown voltage and Zener resistance and forward resistance and reverse resistance we have to observe from this experiment. First, operators. What are the operators? Zener diode is one operator. So you see this is a Zener diode. Zener diode. This one is the Zener diode. Which portion is greater? Red portion is greater there. That's why that is the positive terminal. Black is lesser part is there. That is the negative terminal. This is the Zener diode construction. Now the power supply, this one is power supply of the kit, this one is ammeter, now this one is the voltmeter. We are taking 470 ohms resistance, 470 ohms resistance we are taking, okay. So what is the formula? These are the operators, right? What is the formula? Formula is we have to observe here avalanche breakdown and Zener breakdown. Avalanche breakdown greater than 6 volts we have to apply, we will get the avalanche breakdown. Less than 6 volts we are getting a breakdown, that breakdown we call it as a Zener breakdown. So in between 5 volts to 8 volts it will come based on the diode is greater than 8 volts. Already we know the resistance of the forward bias. You find from the graph, find the slope, right? So then you reciprocal the slope, you will get the resistance of a forward bias. Similarly, resistance of the reverse bias also we have to calculate by using a V2 minus V1 is divided by I2 minus I1. First, how we have to connect the circuit diagram. This circuit diagram is very important. Here, this is a power supply positive. Power supply positive to 470 we are taking here. 470 ohms resistance one end you give that. This is a power supply positive. Power supply positive I am giving into the 470 resistance one end. Next 470 resistance next end to milliammeter positive I am giving, milliammeter negative to, so where milliammeter negative to Zener diode positive. This is the Zener diode positive I am giving. Zener diode negative to the ground. Similarly, voltmeter negative ground, power supply negative also ground. How many grounds are there? You check it. One is voltmeter negative, right? This is the ground. One more is power supply negative. This is also ground. One more is Zener diode negative. We are giving the ground. If it is forward bias, battery positive terminal to Zener diode positive, battery negative terminal to Zener diode negative, such type of biasing we call it as a forward bias. If it is reverse bias, this battery positive terminal we are connecting into the negative terminal of the Zener diode. Here you have to see battery positive terminal I am connecting into the negative terminal of the Zener diode, and battery negative terminal you have to connect it to the positive terminal of the Zener diode. Such type of biasing we call it as a reverse biasing. Just you have to interchange this positive to negative. Now this is the circuit connection. Connection is completed. Once connection is completed, we have to go for the observations. So how we have to go for the observation? First you have to switch on the power supply. I am switch on the power supply. First input voltage you have to set it. Input voltage, this is the wherever positive terminal is there, no, there you have to keep, that is the input voltage. Now you increase, suppose you have to take how much voltage you have to apply. I am applying the 0.2 serial number 1, 0.2 I am applying, right? So now you remove this one, wherever the battery is there, so that diode positive is there, that one you have to keep. 0.2, how much we are getting? 0.19 means almost 0.2. Here is there any current? Zero current is there. Clear? Now again you have to apply. Which one you have to apply? You have to apply more than, so 0.4 you have to apply. 0.4 you have to apply, right? 0.4. So this is the 0.4 I am applying. Now you able to see the output voltage and output current. What is the output voltage? Output voltage is also 0.4, output current is 0. If we apply the 0.4, we are not getting this one, means this is not for germanium diode. If it is germanium, for 0.3 we are getting the current, but we are not getting the current, means it is not germanium. So now we have to keep on increasing the voltage, right? 0.6 I am applying. Once you have to see 0.6 I am applying 0.6. 0.6 I am applying 0.6. You see 0.6. 0.6, right? What is the output voltage and output current? You able to see 0.60. This is the 0.6 volts, 0.60 output voltage. Now output current 0.1. If we increase 0.3 above, we are getting such construction of the Zener diode is silicon Zener diode, silicon made Zener diode, because silicon made Zener diode near the 0.7 we are getting the current. Now again you have to increase input current, input voltage you have to increase, maybe 1 volt you have to increase, 1 volt you have 1.5 I am keeping 1.5. How much voltage is there? So you able to observe the 15.0 you are getting. This is the voltage, input voltage versus which one output current. You take the graph. This is the forward bias, input voltage versus output current. You draw the graph. So this graph will come like this. You find the slope. That slope is equal to delta I is divided by delta V, right? So this is the delta I by V is equal to I2 minus I1 is divided by V2 minus V1. Resistance of the forward bias is equal to reciprocal of this V2 minus V1 is divided by I2 minus I1, which is going to equal to reciprocal of the slope. This will come the ohms. Now you interchange the reverse bias. I mean, coming into the reverse bias, first you take this positive, you connected into the negative, negative you are connected into positive, you have to connect. Clear? So now you able to observe the reverse bias. So you have to take the input voltage, you are able to take for input voltage wherever the positive terminal is there, there you have to apply. Here 1 volts you have to apply, 1 volt for input, direct 1 volt you apply, 1 volt you apply, right? 1 volt I am applying, direct 1 volt. Is there any current? So is not current. Micro you all see, micro you will get the current, but milli you unable to get the current. Clear? So similarly in micro you able to see how much you are getting, that output current and output voltage you able to see, that output voltage is equal to 1.37, 1.3, 1.3, but output 127.6 microamps current is there. But milli is not coming, that's why I am taking as a micro in the reverse bias. And again you have to apply 2 volts, you have to apply 2 volts. I am applying 3 volts first, 3, 4 like that you have to see. 3 volts I am applying. Just you see the output voltage and output current you are able to see. Now you are able to take, so this is the 3.5, 3.5, 3 volts I am applying, 3.5, 3.5 output voltage. So this is the 4.4 we are getting this one. The similar fashion you increase, right? You increase this maybe 6 volts you have to increase, 6 or 7 you have to increase. Now you able to see how it is coming, breakdown is coming or not, you able to see. Breakdown is coming or not, you able to see. Yeah, now you have to see the breakdown is coming. This type of region we call it as a breakdown region. This breakdown we call it as a Zener breakdown. Means the reading is not appearing. The reading is there, but out of the range of this reading, right here. So 100 micro is there, 200 micro, up to 200 only it can be displayed. So above the range of that, so that's why it is unable to see that such type of breakdown. We call it as a Zener breakdown. Now negative voltage I have to apply. The current is gradually increasing like this, and suddenly breakdown. The sharp current is there. Wherever you have to increase the current, you are unable to get the current meter reading. That such type of voltage we call it as a breakdown voltage. From this also you have to find the slope. Maybe you have to calculate the slope here. Here also you able to find the reverse bias resistance is equal to delta I is divided by delta V. Now you find the reciprocal of the slope you have to take. So delta V is divided by delta I, it will come. This is the reciprocal of the slope. Clear? So from this we have to identify 0.7 volts is the barrier potential, or knee voltage, or cut-in voltage. So that is the up to the 0.7 volts, there is no current reading in this current meter. After we are applying the 0.7 volts, there is a current flow is there. So such type of voltage we call it as any voltage. Next, forward resistance you have to write here, reverse resistance you have to write here. From the graph you have to take. Clear? So this is the procedure to find out the V-I characteristics of a Zener diode. So thank you. So please share and subscribe our YouTube channel. Thank you.